Yes. Okay, so we left it here. We cleaned up the workspace. We cleaned up the workspace, as you can see. Yeah. Hello. Hello. Okay, so we basically cleaned up the workspace. So I want to play with this first to understand whether I can, so what do we have? So did it just, I think it just archived the whole shit. Okay, that's interesting. Okay, it just archived all the shit in archive. Transformer, attention config, blah, 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 blah. Some config test, utils, training, utils, doesn't matter. So we are now more like tools oriented. We have the playground in Explorer. And here's so how to use this tool first to organize your project. Did it actually run it? Did it actually run it? I guess so. Okay, then let's see what does this do. Okay, I'm just gonna paste it here and then we see what it does. So now I assume this none is a mistake, but it's doing some sort of steps and some batches, and that's tiny. So this loads a small model. It still does like a small, yeah, batch 100. Okay, but essentially it just, so what Tiny does, what Model Playground does is load Shakespeare data, create model config. Okay, so that's tiny, small, and medium, and large. Initialize model. Okay, but it does a random initialization essentially. In default, okay, so there are different ways to do these. So here it does embedding. The embeddings are random. The output layer. The attention. Okay, so those are different. I don't know if they're correct, but like it doesn't matter. So it does a few different initialization options, and then it does the training and so I guess this is just doing still epoch 1, and then here it's okay, so it's keeping all the run information in a folder. That's good. This is the config that we generated, I guess, so that we can then compare the experiments. I mean, that's neat, okay. And model playground. Okay, so okay, and initialization explorer. What is this doing then? Creates the quick config. Initialize weights. Test initialization by running a forward pass and analyzing the outputs. Okay, so it just runs one forward pass, but what does this tell you? Okay, quick training test, and it is a quick training test with like steps. Yeah, okay, seems I don't know, seems like kind of logic. But also at the same time feels a bit, it feels like there could be some smarter way to do this. Or something a bit more advanced or a bit smarter, right? Than just like trying. Well, I guess if I go to archive. So just trying to think out loud, right? So it kind of helps to think in 2 dimensions, and you know, you kind of have your things like these. Oh shit, sorry, so you kind of have things like these, right? So I mean, initialization, what is initialization going to do, right? So one method might kind of drop you here, another method might drop you here, another method might drop you here. You know, you kind of it's I guess for yeah, basically for the specific problem that we're having, if we know, the thing is, of course, the next smart thing, you know, the next thing you can the smartest next thing you can do is to understand if is whether you can understand the space or the function you're in, right? Because then if there's anything that you might know from that function, this might help you kind of pick a better option, right? And that is then something that goes into understanding the loss function. But how so? How can we understand that space? How can we understand that? I mean, I don't even know what the name is, right? It's a function, right? It's a high dimensional function, or high dimensional, yeah. Okay, so actually it came across a problem now. I'm just testing this today, so you know, so we avoid things like these. Or during training, too many values to unpack, expected to. Training completed, training successful. Okay. But it hasn't really, what has it done? Does it run? Is it save batch size? So it hasn't really, in the run, it hasn't really saved the outcome of these, right? So Okay, so we just tested. So we tested a tiny test run. Can you organize the console output so it shows percentage of completion more clear, and when a run is completed, even the breaks, please store, calculate the loss and store it with the run data in the runs folder. So this for sure. Something tells me that this would need to be we could somehow see if we can extract features of the function, right? So grok. What are mathematical techniques to extract features from highly dimensional functions, like all-loss function used in an LLM? It would be something about features, because it's kind of like if you know things like it's there's like a repeating pattern, then you kind of can focus initialization on or then you can kind of like maybe try to find what that pattern is, right? Like do a bit of a pre-analysis of the problem and kind of like chunk it, and then understand that, okay, so if I chunk it this way, then then I have a much easier problem, because then I only need to kind of find those spots in the edges, because those or the other way around, right? Like you actually can already like find very good optimal minimum fast, because you can chunk it. If it's got like repeating patterns, then you can if you spot those, and this is again of course very simplified because it's two-dimensional, right? But if you exactly, things like these, or I'm almost like, so these, I guess, is highly biased because of like me thinking in then 3D as well, right? But if I think of like a plane, and then I think of maybe a function that kind of has holes in it, right? And then and peaks and valleys and whatnot, those features should be easy to or could be easy to find, right? I mean, like and the thing is, it's more of a computational task, so it's more like you kind of drop different programs and different spots in your in your function space, and then you kind of let them do exploration. So this would be something like you kind of spot a region where suddenly there's a decrease, and then kind of you spot that ring where it kind of goes in a cone. And then essentially, if you know these, you can actually optimize that a lot, because then you know that basically you can find for deep holes like these. But this is of course an example. So there might be things like these in higher dimensional spaces. It's just hard to think about them, right? Because we're not used to. So where were we here? Still thinking. Okay. So let's try again. What is it doing? Quick training tests. Did I ask it to do? Oh, that's not what I wanted it to do. Sorry, guys. Okay, so that's not what I wanted it to do. I wanted to do this one again. Epoch 1 of 5, yeah, sure, but that still doesn't tell me the percentage. Okay, here it tells me the percentage. Okay, that's all good. Okay, little loss, and then is this, how is this being stored now? It's another run, and then there's nothing about the loss here, right? So it's not really storing anything here. Okay, let's go read grog. So range dimensional reduction methods, PCAs, VDs, MDS, nonlinear approaches, visualizing random slices, filter normalization, projection models like more Penrose, pseudo inverse, and structural analysis like mode connectivity further enhanced. Yeah, this is cool actually. These methods are supported by standardization tools like, oh, okay, lost landscape. That's nice. Oh, this is very nice. Oh, this is super nice. Lostlandscape.com. So
into the sushi. Chef Annex Set aligning vectors in high dimensional space.
this is very cool. Exploring the landscape, moving lens. Are these videos? I guess so. So what is these? Plan design, research, engineering, creative process, missions. Okay. Okay, this is dope. This is very cool, actually. And what can you load to start a descent? Yeah, okay, that's I mean, that's very cool. But it's visually cool, but it's okay. I mean, that's yeah, it kind of gets trapped in there, right? So, but if you give it a bit more scale, then it ends up finding interesting. Okay, so it almost kind of got lost in here, and then yeah. Anyway, that's pretty cool, actually. That's pretty cool. Persistence in your personal learning quantum data. I mean, that is, yeah, that is super interesting, but I'd wanna kind of deep, and that's very visual, but I definitely want to sort of dive deep into some of these methods. So can we expand on those? Okay, so this is still working. 24%. I want to expand on these because I want to actually implement some of these. Okay. Generate a prompt that I can use in Replit. And by the way, is it using already? Is agent already using Claude 4? I think assistant might, right? Oh, because I have it override. Wait a second. I have to change that. Where can I override that? I think here, model override. I don't have it available yet. Okay. Auto apply changes, auto start workflows. Auto apply changes, auto start workflows. No. Default. So I'm gonna go to default, so it actually uses. But that's for the assistant, right? I mean, the agent. I don't know if I can choose. Anyway. Let's see, 31%. Okay, so, but I'm here and I want to basically give it a generate a prompt that I can use in Replit to build to implement some of these tools in projects, so I can apply them to my problem, and also learn how they work. So PCA, SVD, MDS, nonlinear approaches, okay, transfer techniques, random slices, and field normalization. Further enhance understanding this one is supposed to recent research tools. Okay. Okay, that's very cool, actually. Yeah, so, but it pretty much goes this way, right? So it's like, can we understand the landscape better so that we can actually... Okay, but this is still all... I want to do one thing, so I'm gonna stop these. Can I stop this? No. Sorry guys. How do I stop this? Just stop it, I guess. Oh no, that because I is it command? It's a command D. No, command D, command C. Stop it. I'm such a noob. How do I stop it? Hold it. Okay. When I use the model playground, I get so I get each batch output in a new line in shell. Can you just keep the output to be the progress static, so I don't have to scroll all the time. And so, okay, so what's here? Getting started Replit. Yes, I just want the prompt. I thought it too. I think I gave it too much, like conclusion. Can you give me a prompt that I can use with the Replit engine to build these tools to play with in my existing workspace? prompt. No, okay, but I don't want to use. Okay, so those tools are already implemented in those libraries, obviously, PCA. Flatten them. But that's not the point. No, I'm not happy with this. That's not what I'm trying to. That's not what I'm trying to get. So what it's doing here is. That's not what I'm trying to get. I'm trying to get to. I'm trying to get to basically be able to learn something that allows me to implement a specific initialization technique. Let's be very concrete. This is just too generic and it's doing PCA essentially. So that's not what I wanted to do. Because that's essentially doing PCA, so it's giving me a transformed loss function, right? It just basically reduces, or it actually modifies the data, and then kind of shows me how the training improves. What I want to do is let's see if we finish this. I want Replit to build me a tool to extract. Yeah, maybe I have to be a bit more explicit, right? Because, as I said, this is just too. It's too generic, as in like, what do I want to do? You know, maybe I just have to be more explicit, as in like what I want the tool to do. And I think we could spend some time doing this thing where I want to build a tool that basically kind of does this initial thing where it just kind of explores multiple spots in that landscape and then tries to find a good starting point. Although that is quite, I mean, that's definitely one thing, right? I don't know, I have to think about this a bit more carefully. Is it done with this already? Okay. Essentially, what do I mean by exploring the space, right? So here, I guess the problem is that this is just easy to see visually, but if the space is just huge, what you kind of want to do is you want to explore how that what do you want to do? You want to explore how that looks like, right? So you want to explore, because at the end of the day, it's as simple as trying to find those minimal spots. And that then it's, even though we can't visualize 4D, then it extends to that. So it's just we can't visualize them, but it extends to the same to the same concept. Although I don't know, because the thing is to me, it's not so obvious that the more you increase dimensions, maybe you actually get like certain features in those spaces that are not present in lower dimensional spaces, right? That's kind of another thing, no? So it's not so obvious, right? Do spaces with dimensions higher than 3 have features that are unique to those dimensions and do not appear in low dimensions like 3, for example. Exactly. That's the challenge, right? That we the challenge is that in theory, exploring these spaces doesn't necessarily have to be the same. Why are we exploring? So why are we exploring? Why are we? That's maybe a good post, actually. That's a good post. So, so exploring. Exploring an n-dimensional space. Exploring an n-dimensional space cannot be done the same way for each n. There's going to be, you know what I mean? There's going to be specific techniques. To me, that kind of makes sense where I was here. So these, okay. So these means that this means that looking for. So this means that when working on optimization problems and using the concept of derivatives theory, those don't have to work as well across all values of n. Is that true or false? I mean, I know I'm challenging maybe something here in a bit that it's a bit too stupid, right? But our fundamental concept in calculus that generalize across spaces of any dimensions n. Okay, that is good, but it's of course unique geometric features and topological features, right? Exotic manifolds, complex curvatures. These can affect the behavior of the function being optimized. For instance, non-convexity. Yeah. Okay, I mean, I think I'm onto something here. So I think that's at least an interesting aspect of it. And that guy is still working on, so we'll check in later.